There's an inverter for a 3-phase compressor. It's a VCC3 inverter. I replaced, it was defective, the compressor would not turn on, and I was able to repair it by replacing these capacitors, 6 electrolytic capacitors. The ones I replaced were surface mount, these 6 right here, and all of them were 33 microfarad at 25 volts. They're the same as a regular through-hole electrolytic capacitor. They test the same, it's just the mounting is different. Now, the real trick is this thing gave me problems, but the real trick was actually the this compound here, and I'm gonna turn this over. You see right here, it will stick. So if you try to tear this, take it apart, then that compound wants to stick to these components, and I've had cases where the components actually rip out along with that compound. So I had to find a way to protect the board so that I could work on it. Now, this is not a general field repair. This is just a repair that I did to prove that, yes, they can be repaired. And how I solved that issue was I used a oven, and I set it to warm, like about right there. This is about 200 degrees for 30 minutes. And that was able to warm that compound up so that I could take it apart safely. So I'm gonna show you how I take these. I'm gonna show you how to test those as well as how to replace them. So these 6 over here are the capacitors that I replaced. And I'm just gonna show you on the meter here, higher is better. We're at 33 microfarads, so we should be in the middle on these. You can see how just the bottom one is blinking. It's not even registering. There's a capacitor there. And I've already checked all of them. They just, one of them I think beeped, but still wouldn't get above the over LED. Now this one is a brand new 33 microfarad, 25 volt, which is the same rating as these guys over here. I'll show you what it should look like. There we go, so even higher than expected. That's a good quality capacitor right there. And I'm gonna also show you how I figured out a way to take these out without damaging the board. It was because these are surface mount, they're a lot more susceptible to overheating. And so what was happening was I was using a regular iron with a fine tip, but it was when I would pull one side up, it would damage the other pad, and that's why I was having problems. So I got this tweezer soldering iron, and I'll just go ahead and take one out here. So you just want to go on either side. Just, hold it there for a good few seconds. You kind of want to wiggle it back and forth to see when the solder's all melted, and eventually it'll just kind of come up on you. What you can do also is just apply a little bit of solder to the outside. There we go. You can see the sec right here, right there and right there, how the pad is fine. And now you can just apply a little solder, cut a regular electrolytic capacitor, one of these guys, cut the leads, and then just solder it in actually pretty easily. I did try soldering a new surface mount, but I found it very difficult to do. It's really not made to be soldered, so I just found it easier to use the standard electrolytic capacitors. The standard electrolytic capacitors that you see here, and here. So there's a total of 6. There's another one, this one right here, which is 220 microfarad at I think 35 volts. I may have to look that up. But on this one, I tested it and it tested good, and so I didn't replace it. But this is my inverter tester circuit from the other video. So I'm just going to plug it straight into the power. 120 volts. And there it goes. All right, so even though on every one that I've opened so far, I found all these 33 microfarad at 25 volt capacitors to be defective, that's not the only way that this inverter can go bad. On one of the ones I've seen, the electrolytic, one of these brute force electrolytic caps had busted from the bottom and leaked electrolytic fluid all over the cover. And on that one also, the second one, even though it didn't leak, it also tested bad. So this is not going to be every repair necessarily, but this could be the repair needed. It would probably take an hour, I'd say, to do this repair. You have to be careful, and you have to have 2 different soldering irons. One is your standard soldering iron, the other is the tweezers. So it'd be a difficult repair in the field, especially with the part cost. I mean, they're $120 for the basic inverter from GE. So it's really, in my opinion, not worth the trouble to repair these in the field. But but we do know that they can be repaired. So even though I don't recommend it as a field repair, what you can do is fix one of these up, put it back in its case, and then make the compressor tester circuit, and then you can have your own inverter compressor tester. So that would be a good use for it, and that's what I'm actually going to use this one for. So, all right, well, that was it. Hope you enjoyed the video, and we'll see you next time.